Hello. I'm Lars Wirzenius. I'm here to talk about error handling in Rust. A bit about myself. I've been using Rust since 2018. Previously, I was using mostly Python for a quarter century, but then Python 3 happened. And Rust is something I prefer. I work for myself. There's a URL there, and you can have a look at on your own. Why should we handle errors? Which one of these is not true? Nobody wants to suggest the one that is not true. They're all true. People have died because errors have been handled badly, and worst of all, if errors are not handled well, people will report bugs. That's really bad and not something you want to experience ever. Different languages have different ways of noticing that there is an error and reporting it back from a function. C usually tends to do error handling or error reporting this way by having some type of value and reserving one magic value saying that this is an error. This is because C came from Unix. A Unix system calls return an integer, and -1 means an error. And the Unix system calls are designed so that -1 being an error never clashes with a real value, except for the time system call. Python, Java, and some other languages use exceptions. If an error happens, the whole function terminates and the caller gets to handle this in some way. This is in some ways cleaner than the magic value because you don't confuse some magic value with real values. So type system is a little cleaner. What usually happens is that Python programs that have an error throw a stack trace to the user, and that's it. Go has a separate error type. And fallible functions in Go tend to return two values. One that represents the successful case, one that represents the error case. And it's up to the programmer to make sure that they always remember to check for whether the error was returned. And usually it will be really obvious to people if they forget, but well, you know people. They don't always do things the right way. Rust, as those of you who know Rust, has a special result type that encapsulates both the success case and the error case. And also the compiler has been told that if the programmer ignores a result value, the compiler should tell the programmer. Unfortunately, this is by default a warning, but it's better, it's not perfect. So how do you handle errors in Rust? The easy way is to panic. In various cases, so the result type in Rust has an unwrap and an accept method. Each of these will check for an error, and if there's an error, they panic the program. This is a really easy way of handling errors. I do not recommend this, especially not if you're controlling the brakes of a car. So, what should you actually do when there's an error in a program? This is not a trick question. It is a very difficult thing to decide. Sometimes panicking is the right thing to do. If you have example code and the only people who are meant to run that code is people learning Rust, then panicking is fine. Students panic anyway. You can try to recover from the error automatically, and this can be done either really stupidly by trying the same thing again and again and again and again. And sometimes this works eventually. Or you might try to do variations of the thing you try to do and possibly land up on something that will work. Or you might tell the caller that this failed, do something. And this is what most actually reliable code seems to be doing. Because the low-level code that actually experiences an error usually doesn't see the big-level picture to know what the actual way to deal with this error should be. You could just ignore the error. And if you do that, your space lander will crash on Venus. You want crash, which is a little like panicking, but can result in really interesting side effects, like having to reinstall your file system. Don't ask me how I know. As a programmer or software designer or someone who needs to decide how a failure should be handled, you need to consider all the use cases, all the people who will encounter this. You will also need to decide what is actually possible to implement. And subsection of that, you need to be able to test your error handling. I have occasionally seen code that doesn't have error handling that has ever been tested. I know this because in some cases, in some languages, it doesn't even compile. So let's say that we have noticed an error and we have decided to report an error to the caller, and the caller needs to give an error message to the user in some way. Possibly after that they will also do something else, but they will at least report an error to the user. What should the error message say?
Example of what it probably shouldn't say. It probably shouldn't explain in very great detail what went wrong, because if it could do that, then you would know what to do right to fix it.
That's one approach, yes.
Also, apparently sometimes customers get very angry when they're told that this didn't work because this and this and this. They're like, well, do it.
Xcode, or what shouldn't do. Microsoft has done this very well.
Mm-hmm. Can we get examples of what you should do?
Always in the file name that was saved open or something like that.
Yes.
Details. Some specific details.
I spent weeks last year figuring out which file couldn't be opened in a program I wrote myself.
Very good, Sami. And also the specific error, so that when the error code first comes to the user and the user calls tech support and tech support knows nothing about the source code, they have something they can write down, and when it finally propagates to the developers, they can still recognize the error.
That's also a good point. This is why Microsoft uses hexadecimal code. Sure.
Please contact your sysadmin. Here's the information.
That's one approach, yes. Note that I'm not saying that any of these are what I would do, but I want more suggestions.
One lovely example from Node.js is, this is probably not a problem in Node.js. Which, I mean, it's true. It's usually a user error or a library error, but it's also kind of fun.
Sure. Before I go to the next slide, I will tell you about the best ever error message I have ever seen. It was a printer that produced an empty page of paper. The actual error was that my printer spooler had run out of disk space. This happened several times. It became okay, this is the problem again. But that was the only problem that only report that I ever got, including syslog. So I have some opinions on what a good error message should be like. I would like the program to tell the user and therefore the support person and eventually the programmer what the program was trying to do. Was it trying to open a file, close a file, remove a file, format the file system, report a nuclear attack, or something else? If it operates on a file, it should say not just the file name, but also the operation. And it should say what the file is, because it gets really annoying when you think you know which file is failing or missing, and then it wasn't that one. The actual problem with the file should be reported, or network resource, or nuclear missile, or whatever. I would be perfectly fine if nuclear missile would be 404, but anyway. And if our code gets an error result from something that we called, we should also pass that on so that the top level code has all the information they need. You should also report what the program actually did after this thing failed. Maybe it decided to terminate. Maybe it, I don't know, painted a picture. If you know with fairly high certainty what the user should do differently, I think it's great to give a suggestion. But I have gotten annoyed myself when those suggestions are inane. Like, use a blue color or something else. Making a good error message is hard. It requires thinking. And you will get it wrong. Do ask me how I know. Everyone gets it wrong, and the only way to get it right is to get it wrong several times before enough people have told you what it should be. It's a little like writing code for paying customers. They will tell you that it's wrong, and then you will get it better. There are various ways in which you can communicate the error message to the user. Write some text to the standard error in Unix is the usual way. It might be put into a log file. For some users, it needs to be going into a Braille teletype or possibly an audio device as speech or something else. This is also something you will get wrong. In Rust, in the standard library, there's an error trait that you do not have to use, but it's handy if you do. In the result type, for example, the error type variable does not have to derive or implement the error trait. It's just that people will look at you weirdly if you don't. The error trait has been evolving in the past several years as the Rust ecosystem has tried to figure out really good ways of handling errors. So from version to version, it might change a little. Things that used to work will continue to work, but the new version might have additional things to offer. The crate that I recommend for creating error types is this error. It's not the only one. There's, I think, at least a dozen different ones, but this error is the one that I have landed on. It makes it really simple to define custom error types, and it provides some helpful features for those. And another crate made by the same author is Anyhow. Anyhow is a way to capture an error, any type that implements the error trait, into an anyhow error. And basically the only thing you can do with an anyhow error is print it out. But printing out is not always the right thing to do. So if you have a library, for example, that provides functions that do things to files, the caller of your library might want to know something what the actual cause of the thing was that failed. Anyhow, doesn't really do that unless you start parsing strings, but if you want to do stringly typing, then I suggest Python or Perl. This error makes it easier to actually capture the source error. This is an example. So you derive both debug and this error to define an enum with error cases for your code. I'm not entirely sure why you have to always derive debug as well. Why can't you do it themselves? But it's 6 characters, I don't care. This error defines the error macro that you can use to define the error message, and you can do string formatting with that quite nicely. And then in each variant you can define values encased within that variant. Pathbuff will then be the name of the file in this case, and then the source error tagged with the source declarator in the second one. Note that the 0 here means the first one, 0th argument to the variant. You can also use not tuple variants but struct variants if you want. I just happen to be lazy and it's easier for my keyboard to type parentheses. Then you have a function that does something with a file name, and if it fails to open the file name, it maps the error to the error case that it defines. This program defines itself. And that's one way of doing that. It's a fairly obvious way of doing that. And so we capture the actual error, the underlying error that happened, and put that into the variant so that the caller will get both. And then eventually, if you just want to print out error messages, the source mechanism in these errors means that you can say the overall thing that failed and then tell the user what caused this overall error, possibly several levels down. The code for doing this looping exists in the standard library, but you need to use the nightly compiler to do that. So it's getting there, but I keep copy-pasting this code because I like the stable compiler. And an example of the output. So the problem I had last year when I was debugging things was that I only got this line. No such file or directory. Operating system error 2. And I was absolutely certain for a really long time that that's the file that's missing. And why can't it find that file? It clearly exists. But it was this file that was actually tried to do. And this file didn't actually exist, so it was clearly very obvious once I inserted enough debugging prints to actually tell me what the file name was. And then I added error cases for that. I'm sometimes a little slow to learn. And a couple of useful links. The first one is a fairly new document from one of the core Rust people, I think, that has a fairly interesting philosophical discussion about error handling in Rust, but also in general. And the second one is the documentation for this error, but that's very easy to find if you know docs.rs. That's all I had. Questions? I can go back here.
I have my microphone ready here, so it's not a question, but actually when you were first time when you mentioned that I want to get the file name when you are trying to open a file and it doesn't exist, it reminded me of the Rust standard library, because that's actually something I would personally think of as a bug in the Rust standard library. When you use the Rust standard library to open a file, what actually happens is that you don't get the, like if it fails, you don't get the file name, and that's actually a problem. So what I do instead, there's a library for that. So there's something called FSR or FSR or FS-ERR. So basically that's one of the like boilerplate libraries I include in everything. I need to add this library that just changes the standard library, or just it doesn't like replace the standard library, but it's like a substitute. So instead of calling stdfs file open, you call stdrfs file open or std whatever, and then you get the errors. It was very important to point this out. Thank you.
That's also a good point. There are many ways of solving of these problems. The Rust ecosystem overall has not landed on one correct way, the blessed way of dealing with errors. That might take a while. And anything that works for you is good, unless you have to maintain it yourself. Other comments or questions?
I think this might work, maybe? No? I can't tell if it's coming from here or from the...
Okay, does this work? Yeah. Great. Going on a tangent, why did you choose debug lines instead of a debugger?
I tend not to use debuggers, and I haven't gotten one to work on Rust in Linux yet. To expand on that, something I did for a really long time was writing software that other people run, sometimes for really long times, and then they tell me it didn't work. And I can't attach a debugger to something I can't get access to. So I started using log files instead, and it stuck. The other reason is that when I started learning how to program on a Z80 microprocessor on the ABC 802 computer, it did not have a debugger at all for any language. But print did work. And learning new things, other people's problem. That was obviously a joke, just so everyone understands. Learning new things is a good thing.
I guess often when you are the developer, you can use S-trace, for example, so it's not a problem. It doesn't help if the problem is something.
Sure. S-trace is also an excellent tool. There are many excellent tools. Debuggers are also excellent tools. It's just that I'm a little old, I'm a little stupid. It will take me a while to learn them.
Is this on? This is on. Sorry about that. I'm going to be asking this every time. Yeah, so anyway, since you don't want to learn or haven't had the time to learn a debugger, then maybe consider programming in languages that have fewer runtime errors.
That would be excellent. My actual goal is to not program and start doing woodworking instead. In woodworking, the worst thing that you can do is you cut off your hand. And you only do that once. No, you can't cut your... if you only have one hand, you can't cut it off. That's a really disgusting joke, sorry. Okay, I guess it's time for the next speaker. Thank you.
All right.